Good morning, all. Am I audible? Kindly respond. Anyone? Am I audible? Shall we start the class? Sugapriya. Good morning. Chalo. Let us start this session. Yesterday I had given some homework question, right? I hope you all have been tried the question. Can anyone drop the answer for the question that I have dropped yesterday? I have asked some question now. Mm, Let me try to drop that question first. Keep smile in your face. Just be calm. Solve the problem in relaxed mode. Okay. Let us go ahead. Here I'm introducing a clock. Can you see in the right side topmost corner? Maths clock 1051. It's a kind of online clock. So hereafter we are going to use this clock in order to set the time period. Okay. It was really difficult for me when I'm saying 2 minutes, 3 minutes. I was also not able to identify the exact time whether we are giving 2 minutes or not, like that. So whenever if we click this, automatically clock will appear directly here. So by using this, I can give 2 minutes, 3 minutes to you all. So based on the given time, you can fastly work out and bring the answer for the question that we are dropping. Okay. I hope you all can see the what I can say clock in the screen, right? Fine. So let me close it. First, let us drop the question once again. Actually, what is the question? There is one AC source that is connected in series with the resistor R. Guys, please come in live. Live means act like a synchronous machine. Don't keep delay between us. Then live stream will not be effective. Okay, I told many times. I hope you people will follow it. So the voltage offered by the supply is V1. The voltage drop across the resistor is V2, and the voltage drop offered by the coil, whole coil they are talking, that is V3. Then what I told, the value of V1 is 220 volt. Value of V2 is 122 volt. Value of V3 is 136 volt. So totally we have 3 voltages. Now the next thing is the question number 1. For the above circuit, what is the power factor of the load or from the source? What is the power factor of the load? That is the question number 1. Okay, Kanaga Savita, good morning. Already you have done the question. Very good. Power factor equal to 0.45. Any other answers? If any one of you solved these questions already, drop your answers. I'm very happy to see your answers. Second thing is, if RL equal to 5 ohm, the approximate power consumption is dash. If the value of RL equal to 5 ohm, the approximate power consumption in the load is dash. The approximate power consumption in the load is dash. The approximate power consumption in the load is dash. That is the next question. Chalo. How many of you solved this? Only one. I am expecting it to be more. If any other. Now I am giving once again 2 to 3 minutes. Okay, now take your time. Try to solve the question. Sorry guys. Let us apply clock. Okay. Now you can take your time. Do it fast. So you can take 2 to 3 minutes. For me it is difficult with the clock. Anyway, so carry on. Any other? Got the answer? Just try it once. You should apply all the ideas, whatever that you are getting. Anyone? Try. Don't get tensed. I'm giving one more minute also. Just try. Anyone? Power factor is 0.9. 1.9 ohm. What is that? PT. The approximate power consumption is 1.9 ohm. Sorry, 9 watts. Manivandan, I got your answer. What is that second one? PT equal to 1.9 ohm. Total power 1.9 watts. You are telling like that. I had given extra time also. Power consumption. Okay, fine. No issue. Nobody got the idea. Okay, I have given almost 5 minutes. Shalom. See, first, let me give you some basic clue in this question. What is the question, first of all? Let us close this. Sure. What is the question first? The given question is, see, they had given the voltage drop across the supply. They also given the voltage drop across the resistor, and they also given the voltage drop across the coil. Now, how do we bring the relation between these three people, sir? Basically, in AC circuits, if you are unable to find out the internal drops or internal parameter directly, there are two ways. Either you can directly analyze the question with the given data. If the data is given, but you are unable to break out the internal relation, like if you observe in this question, the question number one is, what is the power factor offered by the load? Simply they have asked this. And I told you, load means what? There are three people. One is resistor 1. This is called resistor R, and yesterday itself I have drawn this circuit. Now this is load resistor. And this is our inductor L. Anyway, but according to the given data, they are treating this as a coil. Diagram is clearly given. They put this dotted line. It means this RL and the inductor both are combined together and they may be acting as a coil, inductive coil. Now, in order to know the power factor offered by the network, what I have been told you, we must know the phase angle difference between the supply voltage and the supply current. Let me call it as supply current I. Supply voltage is V1. In our network, if you observe, according to the given data, the voltage offered by the supply is V1 only. So, in the phase R, if you know the phase angle difference between the supply voltage and the supply current, then from the theta we can calculate the power factor offered by the network. This is the question number one. Sir, but in order to know this, I have to analyze the entire network. Either you must know the property of either if you are knowing the voltage value V1 in terms of its magnitude and its correct exact position, and if you also know the value of length of the current and its correspondent position, then by finding the phase angle difference by positioning them at the exact position in the phasor, we can easily identify the value of theta. But in this question, polar values of the voltage and the currents are not known. What is the given data is, the one and only given data is, you know the value of V1, V2, V3. Now what is the value of V1 here? V1 is 220 voltage. Now let me ask you a small question. If you observe the question carefully, in our circuit there are two resistor RL, and then we have one inductor. Basically this is the given network. Now supply voltage must be the addition of V2 plus V3. Yes or no? Supply voltage must be the addition of V2 plus V3. Now what I am calling it as, we know this is the RL, and suppose I am calling the voltage drop across this resistor is, we are calling it as VRL, and I am taking this inductor voltage is VL. Basically how will you write the V3 value here? V3 will be the combination of VRL plus VL, that is vector combination. If I want to write it exactly, it should be written like this: VRL plus J times of VL. Can I write like this? This is the value of V3. Observe the circuit property carefully. Because this value of V3, it is the combination of real and imaginary term. Because there we have a coil. In that coil, we cannot take the voltage directly. So remember these things. Whenever they are not giving the internal breakout things, internal property of an element clearly is not given in the question, it means that question can be break with the help of, you can break that question with the help of phasor diagram. Okay, you can try out with the help of phasor diagram. But in order to draw the phasor diagram, a little bit basic knowledge is required. Nothing. Let us see. Slowly we will apply. So first we have to understand the nature of the circuit. So first we have to understand that anyway, one more thing is our circuit is connected in series. If you observe the resistor R, RL, inductor L, and the supply voltage all are connected in series. So the value of current will be remain same at all points. Am I right? It should be. So I am correct, right? So let us continue with that. Okay, sir, this is fine. Now, what shall I do? How will I proceed further? Now, suppose if you want to draw the phasor diagram for this given network, how will you draw? Forget about the all given data. I just what I am asking you is, I have drawn this circuit. நீங்க என்ன பண்றீங்க, சும்மா உட்கார்ந்துட்டு இருக்கீங்க, வீட்ல ஏதோ பண்ணிட்டு இருக்கீங்க. நான் அப்படியே உங்களை கூப்பிட்டு, உங்க எல்லாரையும் கூப்பிட்டு, நான் இப்போ ஒரு டயக்ராம் கொடுக்குறேன், இந்த டயக்ராமுக்கு ஜஸ்ட் ஃபேஸர் டயக்ராம் மட்டும் எனக்கு வரைஞ்சு கொடுங்க அப்படின்னு நான் உங்ககிட்ட சொல்லிட்டேன். அவ்வளவுதான். இந்த மாதிரி ஒரு டயக்ராம் கொடுத்துட்டு உங்ககிட்ட கொடுத்துட்டு, நான் ஒரு சில பேர் மட்டும் வச்சிருக்கேன். ஐம் ஜஸ்ட் நேமிங் திஸ் சர்க்கியூட். இன் டர்ம்ஸ் ஆஃப் அந்த நேம்ல டயக்ராம் வரைங்க அப்படின்னு சொல்றேன். லெட் மீ நேம் இட். ஸோ ஐம் காலிங் இட் as V1. வோல்டேஜ் டிராப் அக்ராஸ் தி ரெசிஸ்டருக்கு மட்டும் நான் வந்து சாரி, that is V2 na according to the given data. 1 minute guys. Yes. So this is V2, and the voltage drop across the whole coil is V3. But now you can break. இப்போ இந்த V3 நீங்க ரெண்டா break பண்ணிக்கலாம், because it is two voltages. One is voltage drop across the resistor, another one is voltage drop across the inductor. Why I am putting VRL? They calling it as load resistance. This is R. இப்போ நான் இதுக்கு உங்ககிட்ட சிம்பிளா phasor diagram வரைய சொல்றேன். How will you draw the phasor diagram? Understand. Basically, supply voltage will be the combination of all the load voltages. So we must start from somewhere. Let me do one thing. I will draw like this. So basically, given network is the lagging network. இப்போ நீங்க careful circuit வந்து observe பண்ணி பார்த்தீங்க அப்படின்னா, our network is having only resistor and inductor. From this, I am clearly guessing that the first data what I have understand is the given network is lagging network. Yes or no? Power factor should be lagging. Lagging means what? Lagging means if I am trying to draw the phase angle difference between the supply voltage and let me assume that the injected current is I. Same current will be flowing through the entire network. Do remember this. Same current will be flowing through the entire network. This. You have to draw the phasor first. So what I have understand here is the current is getting lagging from the supply voltage by an amount of theta. First conclusion. Yes or no? Yes sir. Okay, 1 minute. I will try to create some space. I need we have to keep all the components now. Yes. So let me drop somewhere here. So this is voltage V1 and this is current I. Okay, sir. And I told they are having certain amount of phase angle theta. This is the basic thing that I have understood from the given data. This is lagging network. Definitely current will be lagging from the voltage. Next, if you observe the voltage V2, can you please find out the voltage V2 location in the phasor diagram? Can you please identify the location of the voltage V2 in the phasor diagram? How will you do that? If you observe carefully, let me tell you. The current flow through the resistor R is I. Yes or no? Yes, sir. Now, how will you write the expression for V2? V2 can be written as current flow through the resistor and resistance offered by the resistor. According to Ohm's law, V is equal to I into R. So, from this, if I am converting into polar coordinate, how will you write? V2 is equal to magnitude is I into R only and phase angle is 0 degree. Why? Because it is completely real term. Resistor is completely real term. Phase angle offered by the resistor is 0. So what this 0 is indicate is this is RHS. Yes or no? This is LHS. The phase angle difference between the LHS and RHS is 0 degree. That is the indication. It means we know the location of current already. So V2 also should be placed in the same line. Why? Because the phase angle difference between the voltage and the current is 0 in case of resistor R. Same current will be flowing through the next one. But here if you observe, we cannot individually. Okay, first let me draw individually for your understanding, such that you will get the clear idea. Now let us take the second resistor. Again same current is entering into the second resistor. Just to focus into the resistor. Don't forget about the coil. Later I will come to this term. Now I am focusing on VRL. Now tell me what is the phase angle difference between VRL and I? If you write the expression for VRL, that is the voltage drop across the second resistor. Current flow through the resistor and the resistance offered by the resistor. If you convert it into polar form, it can be written as VRL equal to magnitude is once again I into RL only and the phase angle offered by the circuit will become 0. Why sir? Because it is resistor. Resistor is a real quantity. The phase angle difference between the voltage and the current in case of a pure real quantity will become 0. So what I can further extend, I can keep the value of VRL in the same line. But VRL is not given in the question. We are taking. They have given coil only. I have broken the coil into two of. One is VRL, another one is inductive voltage. Now tell me, now the same current is entering into inductor voltage. Yes sir. How will you write the inductive voltage? Let me write the third term. Inductor voltage can be written as VL equal to, remember, this is J times of omega L into current flow current flowing through the network. How will you write this one into polar form? In polar form, magnitude is I omega L, phase angle should be 90 degree. It is clearly indicating that the phase angle difference, see, from the current, the voltage VL is 90 degree leading. So current, where is the current? Current is placed in this line. This is the current location. So exactly from this point, after 90 degree, I have to place. Remember, guys, listen. I will draw here for your understanding. Suppose current is placed like this. So current oda tipla nama enna panna porom appadina anga irundha 90 degree. I am just adding, I am showing you. Okay. Let me extend this line further. It is placed at 0 degree. Inga irundha 90 degree la voltage fix panna appadina eppadi fix பண்ணுவீங்க? Plus 90 degree. We should go to clockwise. I have to fix the voltage like this. Yes or no? It should be like this, na? You have to understand. என்ன பண்ணோம் 0 degree line அப்படியே extend பண்ணிக்கங்க. This is 0 degree line. From that 90 degree ல வந்து நம்ம என்ன பண்ணோம்னா voltage வந்து fix பண்ணணும். So in the same fashion, if you observe, this is the line. அப்ப இங்க இருந்து 90 degree அப்படின்னா it must be what? Somewhere here. So that is going to be the value of V3. Yes sir, direct aduthu vandu V1 kuda attach பண்றீங்க, not V3, sorry guys, that is VL. அது yes sir V1 kuda attach பண்றீங்க. Now I will tell you. Basically V1 is the supply voltage. Supply voltage must be equal to load voltage. Load voltage means it should be the combination of V2 vector plus V3 vector. This can be further written as V2 vector plus V3 vector can be written as voltage drop offered by the resistor plus voltage drop offered by the inductor. Now, in order to write this in a clear format, I can write like this: V2 is a resistor. V2 is the voltage drop across the resistor. VRL also is the voltage drop across the resistor. This is real component. Plus VL is the voltage drop across the inductor. So the total supply voltage can be written in this format in case of rectangular coordinate. Yes or no? Exactly, sir. Now, if you observe, I have completely traced this question in a proper way. First, I understood that the voltage and the current are lagging by an amount of theta, but the theta value is not known. But what I know is they are lagging because given it is RL network. From that, I have started. After that, what I understood, addition of, see, voltage and the current should be in same phase. I don't know the exact magnitude of the voltage V2, but I understood that that length also will be fixed, positioned at the same line of the current in phase. Again, what we have understood, addition of V2, see, length of V2 will be added with the length of VRL. Both are in the same phase. Why? Both are resistor voltage. It should be in phase with the current. So this is the length of V2, and then we have added length of V2 with VRL. So two resistor value is added. After that, I have added inductor voltage VL. Why it is placed like this? Because it is 90-degree leading from the current. So that's why I'm placing like this. Now addition of V2 plus VRL plus VL should be equal to what? Addition of V2 VRL plus VL should be equal to supply voltage. So supply voltage where it is, அப்ப நீங்க சப்ளை வோல்டேஜ் எப்படி பண்ணணும் அப்படின்னா, ஆரிஜின்ல இருந்து நீங்க ஸ்டார்ட் பண்ணீங்க, அங்க இருந்து VL எந்த இடத்துல முடியுதோ, அதாவது VL அப்படிங்கிறது ஃபைனல் வோல்டேஜ். இட் இஸ் தி அடிஷன் ஆஃப் V2 plus VRL plus VL. அது எங்க முடியுதோ அந்த இடத்துல என்ன பண்ணணும், நீங்க ஜாயின் பண்ணீங்க அப்படின்னா that will give you the value of supply voltage. Basically that is how we are drawing the phasor diagram. So finally I hope you all have got the at least rough idea about the phasor. Phasor is very important, but don't worry, slowly you will be on the track. Suppose sir, I am not having clear idea about this, then watch few more lectures. Not only this, there are so many resources I told you, na, go to YouTube and put how to draw the phasor diagram step by step. I told you, use multiple resources, nothing is wrong. It is your life. I can't say that you have to watch only my lecture, I am covering everything here, then I will not be a good teacher, right? It is my responsibility to set your right path. So this is V2, this is VRL. From this, if I will join, this is going to be VL. This is what we have done. Yes sir, we have completed everything now. So this is going to be V1. That is fine sir. Now let me tell you one more thing. Actually we know V2 is the combination of VRL plus VL. Yes or no? V3, sorry, not V2. அப்ப V3 term இங்க கொண்டு வரவே இல்லையே. See, where is VRL? This is the length of VRL, this is the length of VL. அப்ப VRL எங்க ஸ்டார்ட் ஆயிருக்குதா? This is the starting point. மொத்தமா அந்த வோல்டேஜ் ரெண்டு எங்க முடிஞ்சிருக்கு? VRL plus VL. Terminate ஆகிற பாயிண்ட் this one. So starting point முடிகிற பாயிண்ட் ஜாயின் பண்ணீங்கன்னா you will get what? V3. You got the idea now? Yes. So now we have represented everything in the phasor diagram. V1 is placed here. Yes sir. From that I have placed the current here. Then I have extended this line. We have added V2. Then we have added VRL. Then we have added, sorry, let me extend this. VL. Then we have added V3 also. So now we are having everything with us. Do you know why I am drawing again and again? Such that some of you may not understand initially. Now you may get the clear idea. VL. This is the length of V3. Now this is the total length of V1. This is the total length of V1. Addition of all the voltages. Okay sir, now we got the conclusion. This is the value of theta. Everything is fine sir. What we are going to do now further? I have given these many clues, right? Now use the triangulars, formulas, anything that you want. I just wanted to know the phase angle value of theta. I just wanted to know the value of theta. with the given data, you can do, the length of v1, v2, v3, it is already given in the question. Length is, the data is given now 122, 136, something they had given already, 220, like that. Now, just to predict how to write down the overall expression, v1, we should write the value of v1 in terms of v2, vrl, vl from this phasor. How will you do that? Now, what is this total phase angle? We can write it is 180 degree. Yes or no? See, there is one line like this. If I am observing the line from here to here, totally, it will be 180 degree. From x-axis, if you observe like this, now you will get this is 90 degree, this is one more 90 degree. So this total phase angle can be written as 180 degree. First conclusion. I can write like this. Now suppose if I am treating this one is the phase angle theta 1. Then what is the remaining one? See, let me write like this. Total is 180 and this is theta 1. Then what about this portion, remaining portion? The remaining portion can be written as total 180 minus theta 1. Can I write like this? This total portion is 180, this portion is theta 1. Then the remaining portion can be written as 180 minus theta 1. So I can write that the remaining portion can be written as 180 minus theta 1. Sir, why are you doing like this? I'm just giving some clue. You people only have to identify why I am doing like this. I don't know. I'm just trying out triangular என்னென்ன பாசிபிலிட்டிஸ்லாம் வந்து நம்ம தீட்டா எழுதலாமோ அந்த பாசிபிலிட்டிஸ் I'm just using here. இப்போ நீங்க என்ன பண்றீங்க அப்படின்னா use your basic maths. Okay, take some time. Don't discuss with anyone. This is my humble request. What you have to do is observe, learn the property of triangulars. Triangular classification of triangulars இருக்கும். அதில் என்னென்ன கிளாசிஃபிகேஷன்லாம் இருக்குது, எப்படி எப்படியெல்லாம் ப்ராப்பர்ட்டியை கொண்டு வரலான்னு கொஞ்சம் டைம் எடுத்துக்கோங்க. ஐ எம் நாட் ஆஸ்கிங் யூ டு ஸ்பெண்ட் தி ஹோல் டே, பட் அட்லீஸ்ட் ஸ்பெண்ட் 1 or 2 days, half an hour each and every day, such that try to identify the complete idea of the triangulars. So here I am just bringing one relation, supply voltage square. Supply voltage here V1. So V1 square basically it can be written as, let me write the relation. V1 square can be written as the combination of, slowly identify all type of classification, then 1 minute guys. Okay, sorry. Then you will get V2 square plus V3 square minus 2 times of V1 V2 into cos theta. Sir, how do I get this from the phasor? This is not phasor now. I have drawn the phasor. I am requesting you to predict this from triangular addition. That is parallelogram rule. Of course, exacta solano appadina. These things you will understand once you will get the complete idea about the network, right? That is about the basic property of the triangular. So spend some time in order to get the idea about the network. Okay, once you identify this, then it will be very easy to play with the network. Okay, I hope you all get the conclusion. Okay sir, fine. So from this, if you identify the value of theta, 1 minute, let me try to do this. Now substitute all the values for V1. V1 is 220, already given, 220 square. V2, it is already given. See, this is rectangular addition. I already told you. Then according to parallelogram rule, we can bring this formula here. I might have taught this already in lectures also. I might have proved this. Anyway, learn it one more time. Nothing is wrong anywhere. So V1, V2, V3. V2 is how much? I think that is 122. V3 is 136 square. Twice of V1. Once again 132. Not V1, V2, V3. Sorry. 136. Now if you reduce this expression, you will come up with the value of theta. Let me try to solve this by myself also. So 220 square minus 122 square minus 136 plus 2 divided by 2 into 122, 136. So I'm getting, just wait a minute. Uh, 6, 60. Okay, so sorry guys. Here, this is theta 1, right? 1 minute. I forget to put that. This is theta 1, na? From this theta 1 only I brought this derivation. I forgot to keep this. So from this, you will be obtaining the value of theta 1. I am getting the value of theta 1 is 116.9 degree. 116.9 degree. If you substitute that value of theta 1 here, see that you know the phase angle difference between these two positions. That is 180 minus theta 1. So 180 minus, if you substitute 116.9 degree, approximately I am getting 63.09 something. Now see there, this position and this position. What is the difference between this and this? Almost both are same according to triangular. I told you na, identify the properties of triangular. There you will come up with these properties. I know many of you might be weak in this property. That's why I am asking you to learn this. Okay, go on to learn the properties of triangular. I can say the value of theta and 180 minus theta 1 both are same only. So from this I can place this value 63.09. This will give you approximately 0.45, the value of power factor. Okay, just do remember this. Okay sir, this is one question that is over. See, one thing what you have to understand is this question may looking like a, okay sir, this is very big difficulty. No. Phasor diagram, if you are not aware of the phasor diagram, it will take some time. If you are not aware of the basics of the triangular, it will take some time. But this triangular is not the one that we have to learn in PhD. It is the one that we have already learned in the 9th standard and 10th standard. So some chota fundamental basics are required from the basics. You must learn it from there. Without knowing that, it will be too difficult for us to apply it in some big concepts. Concepts will not be big anyway, you know, really I am solving. So these triangular concepts, we might have crossed in our 9th standards, so kindly go through it once, then apply it. See the properties of similar triangles. When two similar triangles will be placed in the single diagram, how do I get the relation between the phase angle between the first diagram and the second diagram, and what is the relation between opposite sides and adjacent sides between the two similar triangles. These kind of small basics are very important. And remember one more thing, these triangulars will be also playing an important role in electrical machines parallel operation of synchronous alternator. You might be knowing that there is one chapter is called frequency drooping characteristics of the alternator. Similarly in DC machine, same thing will be drawn in between power versus speed of the DC motor or DC generator, whatever it is. Maybe it is generator only we should focus on. That is the drooping portion. So there, understanding these similarity properties of the triangular is very important. Until otherwise you will not be able to crack those questions. So it is very important to knowing the basic properties of triangular. Be patient and put it in YouTube also. Someone might be taught these things clearly. Sit and make some hint clearly, and then come back to the circuit and how do I apply these basics, how you got this relation. Like that, if you try, you will get the answer. It is over. Okay, fine sir. Now I am giving one more work here. They have asked one more question. This is really very good question. We have learned a lot, right? How to draw the phasor and how to develop the equation from the phasor. They had given one more question. Now this question can be solved from the phasor directly. The value of RL equal to 5 ohm. What is the approximate power consumed by the load? I think according to the given data, they are focusing only on this load. Yesterday I told you that they are talking about total power consumption of the load. That is wrong. See that if RL equal to 5 ohm, then the approximate power consumption of the load only they are asking. And RL means load resistance. So they are talking about only this 5 ohm resistor, not the overall one. Kindly forgive me for that. Yesterday I haven't gone through the question properly. Fine, sir. Basically, we know how to calculate the load power consumption. Yes or no? Either it can be written as this load power can be written as VRL square divided by RL, or we can write this one as IRL square into RL. Both are same only. Am I right? Current flow through the resistor into resistor I square times of. This is the basic formula. Now it is your job to identify the value of this VRL. How will you calculate the value of VRL now? Let me show you. 1 minute. Okay. Come back to the given phasor diagram. Now from the phasor diagram, we must identify the value of VRL. Sir, how do I identify? Now you know the value of theta, you know the value of that is phase angle at all points. Yes or no? Now it is very easy to bring out the overall answer. What you are trying to say. Let me draw the phasor one more time. If you observe, this is V1 and here we placed V2, VRL and VL. Okay. Yes, this is VL. But where is V3? This is V3. V3 is already given in the question. You know the value of this theta now. What is the value of theta? The theta is I think approximately we found 63 point something 909 or something I got, right. So this value we know. Theta value we know. Fine, sir. Theta value we know. Now how will you project? Suppose if I am calculating cos theta only for this triangular. Guys, take like this. Don't think too much. There are two lines like this. Okay, I'll be drawing like this. 1 minute. I hope you all have understand already, but I'm drawing one more time. See how it is like this. How it is looking like this. This is VRL, this is VL. And if we join these 2 points, that can be treated as V3. And this is the position of theta. Now if you take cos theta, how will you write the value of cos theta? Cos theta can be written as adjacent by hypotenuse. Adjacent is VRL. This is adjacent. Hypotenuse is V3. From this I can write the expression for VRL. So VRL can be written as V3 into cos theta. The value of cos theta is approximately already we found, that is 45.45. Value of V3 is already given. V3 I think 122 no? Sorry 136. 136 into 0.45. If you substitute, that will give you the value of VRL. That's all. Already the value of R is given in the question. RL is 5 ohm. Now by substituting these two values, you can easily identify the value of what? Power consumption. Just to come back to this formula, substitute the value 136 into 0.45 divided by the value of, sorry, whole square. This is V square na, divided by 5. That is the power consumption of the load. See how easily we got this. So in some cases, it is very important to learn about the phasor diagram. Because without knowing the phasor diagram development, you may not be able to crack the question. But I think this is very good question and it is very easy question too. What you have to do is just to spend some time to learn about the properties of that basics I told. Chalo, let us go ahead with the next question. So the given question is, two magnetically uncoupled inductive coils have quality factor Q1 and Q2. Two magnetically uncoupled inductive coils, they are having two magnetically uncoupled inductive coils. Okay, two magnetically uncoupled inductive coils. Coils have Q factors. They are having certain Q factor. These coils are having Q factors Q1 and Q2. They are having two Q1 and Q2 RTD. Choose an operating frequency. Their respective resistance. For these coils, respective resistors are R1 and R2. You know, coil means how will you represent? Coil will be the combination of resistance plus inductance only. So they are told there are two uncoupled magnetic coils. So each and every coil will be having certain resistance. That will be represented as R1 and R2. When these coils are connected in series, what is their respective affected quality factor at the same frequency? Initially, they are operating these two different coils in the same frequency. Some let us say these two coils are separated initially and they have operated at a frequency of FM. Now these two coils are going to be connected in series. If I will connect these two coils in series at the same frequency, what is the net quality factor? That is the question. You might have understand this question. Let me, for your understanding, I will do one thing. I am putting Q1 equal to 3 and you can take value of Q2 equal to 5 such that your answer will be in numerical. First, என்ன பண்ணிருக்காங்கன்னா, they have two coils, they are separate. When they are in separate, the quality factor of the coil 1 and coil 2 is Q1, Q2. That's all. Now, those two coils are going to be connected in series. If we will connect them in series, what is the net quality factor? That's all. Proceed further and bring out the answer. And they told that in both of the cases, they are trying to run the circuit at the same frequency. Do it first. So what you can do is, you can take 2 minutes for this question. Just first. So you can take 2 to 3 minutes. Already I had given 1 minute, so you can take 2 more minutes. Drop your answer in the comment section. What is the net quality factor? Are you people are just in live stream or delayed? So you have 1 more minute. Okay, your time is over. Almost. I don't know how many of you appeared for GATE 2020-22. This same question had been given in GATE 2022 with the same data, but last time they have given just Q1 Q2. This time, instead of giving Q1 Q2, what they have done is they have given some certain values, like I told na, Q1 equal to 3, Q2 equal to 5, like that they have given some values, but both are same only, almost same question. Anyway, first let us understand the basic. Now I am taking one circuit here. According to them, there are two coils, right? I will draw one coil now. For the coil, how will you identify the quality factor? Tell me, what is the formula to obtain the quality factor of a given coil is having the value of R and L with a certain frequency F. Frequency F, or you can take omega. You know, they are directly proportional. Omega equal to 2 pi F only. So the value of quality factor can be manipulated, can be calculated with the help of R and L. In case of a coil, it can be written as Q is equal to omega L by R. This is the general formula. I hope you all know this. Now when I am having coil 1, now let us take. Suppose if I am having a coil 1 and its correspondent quality factor, they told that that is Q1. Like I can treat this one is R1, this one is L1 with the correspondent frequency is omega. So we can write the quality factor of the coil. They are using small q, right? So I am writing Q1. So Q1 can be written as omega into L1 divided by R1. Why I am not putting 1 for omega? Because omega is constant. They clearly told. Treat this one as the equation number 1. Now let us keep our attention with one more coil. Initially these two coils are separated each other. There will be no relation between them. So this coil is R2, its inductance value is L2, frequency is once again same omega. Now if you calculate the quality factor for the second coil, they are using once again Q2. Q2 is equal to same frequency, but the value of resistance and inductance may not be the same. Let me treat this one as the equation number 2. Now what they have done is, in the resultant case, they have taken both of this coil. Coil number 1 is interconnected in series with the coil number 2. Yes or no? I did not told. In your question, they told. Now forget about the first two cases. First case. Now simply there is one network. In that network, some resistor is given R1, R2, inductor value is given L1 and L2. After connecting these all elements in series, first of all, what will you do? While if I am asking you to calculate the quality factor of the net total circuit, given circuit, generally what you will do is, let me take the net quality factor. In order to know the net quality factor, same frequency. First what we have to do, there are two resistors in the circuit. So if you want to know the net quality factor, we must add both of these resistors. Yes, both are connected in series, though the total resistance will become R1 plus R2. First conclusion. Quality factor Q is equal to omega L by R only. So omega is fixed. How will you write the inductance? So it can be written as omega into L1 plus omega into L2. Anyway, omega is common, you can take it out. So I can write L1 plus L2 upon R1 plus R2. That's all. This is the overall quality factor. But now the question is, they haven't given the value of inductance, resistance, anything. They have given only the value of Q1 and Q2. I asked you to take Q1 and Q2 equal to 3 and 5. Later I will come to that. In your question, they haven't given this numerical value. Now what will you do? Q1 you know, Q2 you know. Now write the net quality factor in terms of Q1 and Q2. How will you write that? If you observe, Q1 has been expressed like this, omega L1 divided by R1. Q2 has been written like this, omega, sorry guys, here I made a mistake, omega into L2 divided by R2. So we know the value of Q1 and Q2, but how they have written omega into L1 divided by R1. Now if I will expand this, let us see, omega into L1, omega into L2. I can write like this, but what is wrong with this circuit? Denominator terms are missing. In the first case, omega L1 divided by R1 is missing. In the second case, omega into L2 is there, but divided by R2 should come in order to write this expression in terms of Q. So what will I do? I will take this expression once again. I am remodifying the net quality factor. Shall I write like this? See, first already omega L1 is there. I am multiplying numerator by R1 and I am dividing your denominator by R1 plus I am taking the already omega L2 is there. I am multiplying your numerator by R2 and I am dividing your denominator by R2. Overall denominator is having R1 plus R2. Now, shall I write like this? We know omega L1 by R1 can be replaced by Q1. Exactly, sir. So, Q1 into R1 plus omega L2 by R2 will be replaced by Q2. So, this can be written as Q2 into R2. Should I write like this? Yes or no? Yes, sir. So, whole divided by. You can write R1 plus R2. So, I forgot to give the value of R1 and R2, right? Forgive me, guys. So, this is the overall answer, net quality factor. So what they have given in the question, the value of I told q1 equal to 3, q2 equal to 5. If you substitute that, then also this expression will become in terms of R1 and R2 only, right? So it is not possible to get the numerical value. R1, R2 should be required. Anyway, I forgot to give that. This is the net quality factor. Same question has been given in the last gate. But nothing they have done. That's just they did some modification. I hope now you have understand how to write this quality factor in terms of Q1 and Q2. Yes, sir. Chalo. So this is the net answer. Let us go ahead with the next question. The next question given here it is 1 minute. At least I am expecting answer for this question from your side. There is one AC source. It is connected with the capacitor. One more AC source connected with the inductor. One more AC source connected with the nothing. So it is connected like this. Okay, like this. That is the given data. And they told that current flow through this circuit is I. This inductance value is J times of 1. This is minus J times of 1. They are calling it as V1, V2, V3. Now in the question the value of V1 is given. V1 equal to 100 at an angle of 0 degree. V2 equal to 100 at an angle of minus 120 degree. V3 equal to 100 at an angle of plus 120 degree. So V1, V2, V3 everything is given. Now what is the value of current expression? Can you please tell me what is the magnitude and polar phase angle offered by the current I? Take your time, do whatever you want, but bring the answer. Do it fast. I will give a clue for this question, but I will not give answer for this question. Drop your answer. You can take 2 to 3 minutes. No issues. Be conscious. Do it fast. Keep smile in your face. Face is serious that will not be good. At least while preparing. Practice பண்ணும்போது smile light. It's a simple question. See, one or two questions வந்து little bit வந்து நீங்க கான்செப்ட்ல வந்து லேகா இருந்தா லைட்டா டிஃபிகல்ட் இருக்க மாதிரி ஃபீல் ஆகும். இட் ஷுட் ஹேப்பன். எனிவே இந்த கொஸ்டினை சொல்ல முன்னாடி இந்த ஃபேஸர்லாம் பார்க்கும்போது யூ மைட் பி ஸ்ட்ரகிள்டு ஒன்லி ஒன் ஆர் டூ கொஸ்டின்ஸ். அது என்ன ஆகும் அப்படின்னா ஃபண்டமெண்டல் பேசிக்ல லேக் ஆயிருப்பீங்க. அதெல்லாம் இதுக்கு தான் இந்த மாதிரி கொஸ்டினை சால்வ் பண்ணும்போது கொஞ்சம் டீப்பாக அனலைஸ் பண்ணி அது ரிலேட்டடாக இருக்க கான்செப்ட்ஸ்லாம் கற்றுக்கணும். ஸோ நீங்கள் அந்த மாதிரி கற்றுக்கும் போது ஸ்லோலி ஒரு டைமுக்கு அப்புறம் பேசிக்ஸ் எல்லாத்தையும் நீங்கள் திரும்பவும் ஸ்ட்ராங் ஆனதுக்கப்புறம் there will be no question which you cannot be able to solve. Definitely you will be able to crack all questions. So try to get the grip with the basics. Anyone got the magnitude at least for the current? You can apply nodal if you want. It has been very long time now, so you can try it once. You can apply nodal. I'm just giving some clue. Not clue, so it is not necessary, but my suggestion is you can go with the nodal to find out the current, or else you can do whatever you want. Choice is yours. Anyone? Your time is over. Almost 30 seconds more. No one? Sure. Listen, let me try to solve the question. Actually, what is the question? Sir, the current flow through the circuit is what? And they told that the value of V3 is under a triangle of 0. 1 minute. I think this is V1, V2, V3 now. Where is the question? V1, V2, V3. Yes. So, and V3 values are already given. 0 degree, plus 120, minus 120. Everything is given, sir. Fine. Let us substitute the values first, because all the magnitudes are same. When the magnitudes are same, how do I predict the nature power flow? In which direction power will be going? For that, a little basics are required. Let me enter into power system. Basically, what will happen is in power system, I am introducing a small concept. Just listen to this network. Let me take one equivalent circuit here. You might have seen this often in power system. So basically, at the receiving end, this portion is connected with the loads. It is going with the loads. And at the sending end also we will have a bus, and this portion is connected with our superstar, that is alternator. Now here we will be mentioning the voltage V at an angle of delta. Here we will be mentioning the voltages V at an angle of like delta 1 V1, let me call V2 delta 2. So now suppose here what happen is the value of we will be dealing with the two powers. Let me tell you everything. We will be dealing with the two powers. One is called real power and another one is called reactive power. According to decoupling phenomena, you will be come to know the meaning of decoupling phenomena when you are entering into power system. So real power is dealing with the proportional to the value of delta. Reactive power is proportional to the value of magnitude of the voltage. So real power basically will be decided. How we are predicting the nature of the real power flow? That can be decided by the value of delta. So what is the meaning? Current real power will be flowing from higher value of delta to lower value of delta. Direction of the real power. Similarly, reactive power flow can be predicted from higher potential point to lower potential point. That is the basic definition. Now, suppose if the value of potential is remains same, higher potential value, lower potential value, in both point if you are having same potential, then there will be no any reactive power flow. only you can observe real power flow. In our case, if you observe, they told that the value of the voltage, suppose if it is given as 100 at an angle of plus 120 degree, and here we are having 100 at an angle of 0 degree. In this case, if you observe, the value of magnitude of the voltage V1 and V2 both are same. So in this network, there will be no any reactive power flow. It will be 0 volt ampere reactive power. First conclusion. These basics are very important. I will be coming back and I will be telling why I told you. But you can observe only real flow will be there. Why? Because the value of delta 1 is plus 120 degree, value of delta 2 is 0 degree. So how power will be flowing? Power will be directed from delta 1 to delta 2, because I told you real power will always flow from higher value of delta to lower value of delta. So from this I can predict the direction of the power flow. Similarly, suppose if the value of V1 at an angle of delta 1 is 100 at an angle of plus 120 only, but the value of V2 is 100 at an angle of minus 120. Now tell me what will happen. Still, even in this case also, reactive power flow will be 0. Why? Because voltage in this given network at both point is same, sir. So there will be no any reactive power flow in the network. What about the real power? Definitely real power will flow. Plus 120 degree is higher than the value of minus 120. So real power will be directed from here to here. So finally what I have understand is the value of V1 is clearly given as 100 at an angle of 0 degree. Value of V2 is clearly given as 100 at an angle of minus 120 degree. But if you observe, the value of V3 is given as 100 at an angle of plus 120 degree. So now one more question is, if I will start from here, this node in between, see, let me ask you, in between this node, just observe the portion where I am marking. In between this node and the supply voltage, in between this, do you have any loads here? No, it is simply a short circuited line. So what is the conclusion here? I can directly take this voltage V3 up to this point, because it is going to be same even up to this point, because between these two node also nothing is there. So same voltage will be appearing all these points. Yes or no? Yes, sir, you are correct. So now from this I have understand the value of voltage is going to be V3 at this junction. Now let me redraw for your understanding. Now there are three sources basically. Source number 1, source number 2, source number 3. So all will be connected. One is connected in series with a capacitor. Another one is connected in series with the inductor. And another one is connected like this. Okay. Fine, sir. And now you know this is 100 at an angle of 0 degree. This is 100 at an angle of minus 120 degree. This is 100 at an angle of plus 120. This 100 at an angle of plus 120 will be appearing this point also. Here also we have same 100 at an angle of plus 120. I told you the reason just now. Now the question is, what is the current supplied by this source? Already we have predicted. Though we are having two more sources here, I am having one more voltage source here and here. But I have understand that these two branches are going to consume the current I1 and I2. Why, sir? How did you told that? Because we have predicted, reactive power will not flow. Definitely, only real power will be flowing from here to here. And I have told you the reason also why real power is going, why reactive power will not be going. We have decided based on the decoupling phenomena. I have explained the things here. I told you, if you are very strong in circuit theory, automatically you will be breaking the questions in power system, electrical machines, power electronics, electrical measurements, analog electronics. Everything will become very easy. So, but it is very important to understand the subject of circuit theory is very important. Okay, sir, fine. Let us continue. Now, if you apply KCL, I can write the expression for I1. I can be written as, according to Kirchhoff current law, it will be the combination of I1 plus I2. Can anyone please tell me what is the value of I1? I1 will be the current flow through in the capacitor. It is given the value of capacitor reactance is minus J. Minus J into 1 is minus J only. This is plus J. How will you write the expression for I1? I1 can be written as higher potential point 100 at an angle of 120 minus lower potential point 100 at an angle of 0 degree. This is the voltage drop across the capacitor. If you find the potential difference between the terminals of the capacitor, there are two terminals. In this terminal, I am having 100 at an angle of plus 120. In the another terminal, I am having 100 at an angle of 0. Just to directly take the difference. Guys, in AC, you cannot guess the polarity. I told you, na, either in both sides, you must go up with the same polarity only. Either it should be plus or minus, but it reference is always positive only. I'm just going up with the positive. It is not DC to check which plate is connected here, positive plate or negative plate, because AC is a bidirectional supply. It will be flowing in positive direction and both negative direction also. So you can directly always take positive in both sides and find the difference. Okay. So after finding the potential difference, now we got the voltage drop across the capacitor divided by C. Basically, minus J can be written as 1 at an angle of minus 90 in polar coordinate. So I am writing, because numerator term is in polar, I am writing denominator also in polar. Again, we will convert later. Plus, write the expression for I2 in the same fashion. 100 at an angle of plus 120, sir, minus 100 at an angle of minus 120, sir. Yes, divided by, how will you write the expression? See, first step, find the voltage drop across the inductive reactance. Then voltage divided by reactance will give you the current flow, same fashion that I am following. In the DC also we have done the same, right? So this can be written as 1 at an angle of plus 90. Now reduce the expressions. So if I pass this minus 90 to the numerator, it will become plus 90. You can take 100 outside. If I will take 100 outside in bracket, it will become 120 minus 0 degree. Yes, sir. And with this, we are going to add one more plus 90 degree. The term that is coming from denominator. And 1 is 1 only, you can leave it, right? We no need to give importance for that. Let us continue anyway. And here also, if we take 100 outside, in bracket, you will be having, here it is plus 120 minus at an angle of minus 120, and with this we are going to add one more minus 90 degree, which came from denominator. Now let us expand it further. See, if you pass this at an angle of plus 120 inside, it will become what? It will become 210 degree. We have to add the phase angle, remember. Minus, it will be what? 90 degree, 0 plus 90. And plus 100 into, this can be 120 minus 90. So first term will become 30 degree. Minus second term will become minus 120 minus 90 will become minus 210. Okay, sir. Now let us convert it into rectangular form. This 210 can be written as e power j 210. Yes, sir. Minus at an angle of 90 directly can be written as j. We all know. Similarly, plus 100 into 30. This can be written as e power plus j 30. Do it fast by yourself. You can do it hereafter. You can expand this. E power minus j 210. Yes, sir. Let me expand it further. So it can be written as 100 into, I am directly multiplying 100 inside now. E power j 110 can be written as 100 into cos of 210 plus j into 100 times of sine of 210. Then minus j times of 100. 100 is common for this both term, na? So all with all terms 100 will appear. Again, with the second expression, I can write like this: 100 into cos 30 degree plus j times of 100 into sine 30, and then minus 100 into cos 210, then plus j into 100 into sine 210. Guys, just observe here. இங்க ஒரு மைனஸ் இருக்கு இல்லையா? எஸ் சார், ஹியர் we are having one minus. அப்புறம் இந்த e power minus, இங்க ஒரு மைனஸ் இருக்கா, அதனால தான் இங்க minus into minus plus ஆ இருக்குது. Sir, how you are putting plus here? Okay, fine sir. Is there any term getting cancelled out? 100 into cos 210 minus 100 into cos 210 will be cancelled. Anything else apart from that? I don't think so. Right now you can reduce the remaining terms. J into 100 sin 210, j into 100 to sin 210 will become twice. Right, so that's all. Now hereafter you will be taking care, na? So just find out the value of cos 30, then sin 30 degree, add everything, you will get the resultant current expression. Okay, I don't want to go further because almost I have given answer. But my sincere suggestion, while solving problems in AC circuits, it is very important to go with the conscious brain. If you leave any single polarity or single mistake, if you did, then the entire circuit will goes wrong. Then you will be thinking that you are not aware of the concept. உங்களுக்கு எல்லாமே தெரிஞ்சிருக்கும், but because of your what I can say unconsciousness, you might did the mistake. நீங்க வேற மாதிரி நினைச்சிட்டு இருப்பீங்க. So be careful with the problems with the AC questions whenever you are solving it. Okay, that is very important. Chalo. Now let me drop the next question. One minute. So there is one capacitor, resistor, both are connected in series. Again, there is one inductor and a resistor. This is also connected in series. This resultant combination will be in parallel. Okay. Now they are going to be excited by a AC source. Okay, sir. This is given. Then they told that the value of inductance is 0.02 Henry. Value of the resistor is R. This is also R. This is 100 microfarad. Everything is given. Now the question. The circuit below is excited by a sinusoidal source. The value of R in ohm, for which the admittance of the circuit become pure conductance at all frequency. Question is, what is the value of R when the value of overall admittance offered by the network will become pure conductance? That is the given. Given data நான் கொடுத்துட்டேன். Find the value of R for which the admittance offered by the network is becoming pure conductive அப்படின்னு சொல்லியிருக்காங்க. Take 2 minutes. Okay, try to bring the answer. Your time is started now. Take 3 minutes also, no issue, but understand the question. Don't memorize anything. Admittance calculate பண்ணுங்க. அதுல conductance மட்டும்தான் வேணும் அப்படின்னா என்ன நடக்கணும்? Conductance அப்படிங்கிறது ரியல் பார்ட் தானே. சீரியஸ் சர்க்யூட்ல ரெசிஸ்டர் அப்படிங்கிறது ரியல் பார்ட். அதோட ரெசிப்ரோக்கல் தான் கண்டக்டன்ஸ் பேரலல் சர்க்யூட்ல. அப்ப இமேஜினரி டேர்மை 0 ஆக்க சொல்லியிருக்காங்க. அப்படிதான் யோசிக்கணும். அப்ப இமேஜினரி டேர்மை 0க்கு ஈக்குவேட் பண்ணா something will be happening there. Maybe we will be able to find out the value of R. Finish now. I have given the clue. Try now. Bring the answer. Anyone got the answer? Just to find out the value of R when the circuit will be producing pure conductance. When you are calculating admittance, imaginary part of the admittance will become 0, na? Anyone? Time is over. Okay, listen. Let me try to solve this question. Nothing is there. Just relax. Okay. First of all, this resistor and the capacitor both are connected in series or not? Yes, sir. So let us calculate first value. Let me call it as Z1, impedance Z1. Series means impedance only. How will you write that one? R, okay. Capacitor can be written as minus J upon omega C. Now let us focus on the value of Z2. Z2 means second branch, this one. Here there are two people connected in series. One is R, same resistor, another one is inductance, J times of omega L. Fine, sir. Now if you observe, branch number 1 and branch number 2 both are connected in parallel. So when they are connected in parallel, how will you calculate the admittance? Basically admittance, Y is equal to, it is the combination of Y1 plus Y2, that is admittance offered by the first one, admittance offered by the second one. But we know admittance is the reciprocal of impedance. So this can be further written as 1 by Z1 plus 1 by Z2. Yes, sir. What is the value of Z1? We have calculated just now. Substitute that value. This can be written as R minus J upon omega C plus second one can be written as 1 upon R plus J omega L. Is there any problem now? No, I don't think. Now, if you take cross products, like I am taking LCM, I am bringing this term to the numerator, this term to the this numerator, such that this can be further written as R plus J times of omega L. Similarly, here, 1 minute. What we will do is, if we go like this, the derivation will be a little bit lengthy. Guys, 1 minute. 1 minute. Let me try to solve it simply. We will avoid this because my mind is going with many steps. No, stops. See, first of all, I'm giving one small suggestion. Always we know whenever if complex term is appearing in the denominator, what my suggestion? Take its conjugate, multiplying it in the denominator and numerator, such that denominator will become purely real. Do the same thing. Now, if you observe here, first term, here also denominator is rectangular one. So take the complex conjugate for this such that it will become R plus j omega c in the numerator. Denominator will become what? A minus b into a plus b. Basically in the denominator already R minus j omega c is there, j upon omega c. With that we are multiplying it by R plus j upon omega c. So second term, if you observe the second term, already R plus j omega L is there. So I am multiplying and dividing it by R minus j omega L such that denominator will become R plus j omega L, R minus j omega L. Yes, sir. So now from this, how would I write the further step? So numerator will become R plus j upon omega c. Denominator. If you observe the denominator, it is a minus b into a plus b. What is the formula? A square minus b square. What is the value of a? That is r square minus what is the value of b? J upon omega c whole square. Similarly, second term. In the numerator, what we are having? 1 minute. Yeah. R minus j omega L. Yes. In the denominator, R minus j omega L into R plus j omega L. That is A plus B into A minus B. Then this can be written as A square minus B square. Next step. Now this can be further written as R plus j upon omega C. Denominator will become C. If you square this j, it will give you one more minus 1 because that is operator, imaginary operator. Already one more minus is there. So minus into minus will become plus R square plus 1 upon omega square C square. It is over. Plus second portion R minus j omega L. denominator in the same fashion, if you write r square plus will be appearing here. Why? Because the operator j, it will give you j square, minus into minus will become plus omega square into L square. Now if you observe in both term, imagine denominator will become purely real. Now it is very easy to break the real part and the imaginary part. Anyway, okay, let me break it. Real part, first case, real part can be written as r square plus r upon r square plus 1 upon omega square c square. Imaginary part of the first term is j times of omega c, sorry, 1 by omega c upon 1 upon, sorry, r square plus 1 upon omega square c square. For the second term, once again, real part will become r upon r square plus omega square L square. Imaginary term minus j times of omega L upon r square plus omega square L square. Yes, sir. Now it is very easy. See, there are two real terms. This is real term, this is real term. Combinedly, this is called conductance. Because we are calculating admittance only. Since I am estimating the value of admittance only, see there, it is the expanded version of admittance only. So the real part will be gone. We are keeping, so okay, real part will be there. Imaginary part will going to be equal to 0. There are two imaginary term, 1 and 2. So let us take only imaginary term. It will become 1 upon omega c. In the denominator, we will have r square plus 1 upon omega power 2 c power 2. And then minus omega L upon, we will have r square plus omega square L square equal to 0. This is the complete imaginary part. Addition of this one and this one. Okay. It is going to be 0 now. Now if I will pass this term to the right side, such that we will be having 1 upon omega c in the denominator, it will become r square omega square c square plus 1 whole divided by omega square c square. Can I write like this? I am just doing cross product. In the right side, it is becoming omega L upon r square plus omega square L square. Now further, see that denominator of denominator will be going to the numerator. So this omega square c square will be coming here. Already 1 by omega c is there. So it will be like this, omega square c square upon omega c. One omega will be cancelling, one c is cancelling. This can be further written as omega c upon r square omega square c square plus 1 equal to, here it can be written as omega L upon r square plus omega square L square. Anyway, what is the question? The value of r is dash. That is the question, right? So in the given network, we were supposed to calculate the value of r only. Okay, sir, fine. So let us further continue this. Observe this, right side and the left side. Omega is getting cancelled out in the numerator. So we have only c and L in both sides. So let us continue it further. So we have c upon ஏசியை பொறுத்த வரைக்கும் ரெக்டாங்குலர் போலார் இதெல்லாம் வர்றதால கொஞ்சம் டைம் ஆகும் டெரைவ் பண்ணுறதுக்காக. அதனால தான் ஸ்கோர் பண்ணும்போது நம்ம ப்ராக்டிஸ் பண்ணணும். நீங்கள் நிறைய வீட்டில் சால்வ் பண்ண டைமுக்கு அப்புறம் இட் பிகம் வெரி ஈஸி. See, for your understanding, I am solving like this. In my case, when I am solving, I will be skipping 2-3 steps directly. It should automatically come. It is not like you can do, I cannot do. Nothing is there. There is no one is called a faculty. There is no one is called a student. All are learner only. The person who is continuously doing the practice, he will become the master. That's all. So நீங்க continuously பண்ணிட்டே இருந்தீங்கன்னா you will become the master. Nothing is there. Okay. Okay, let us continue from this. I am passing this to here. I am passing this to here. So c into r square plus c into omega square L square equal to, here L into r square omega square c square plus L. Anyway, what is our target? We are focusing on the value of r square. So bring this term to the left hand side, pass this one to the right side, such that this can be further written as c r square minus L into r square omega square c square equal to c omega square L square minus, this is minus plus L. Did I left any term anywhere? I'm not sure. I don't know. I'm just going with the values that is coming. If I did any calculation mistake, do let me know in the comment section. It is your responsibility. Sometimes unconsciously it will be happen. L minus C omega square L square. So finally, what I will be getting here? R square equal to L minus C omega square L square upon C minus L omega square C square. Yes, sir. So now from here you can take C in the numerator, you can take L outside, in the denominator you can take one C outside. It will become 1 minus C L omega square. Here you can take, if you take C already the 1 minus L. Am I right? I have taken 1 C outside, L C omega square. Finally, if you observe, numerator and denominator are getting cancelled out. Yes or no? So just continue till the last point. So R square equal to L by C. Or we can say R equal to plus or minus square root of L by C. But negative value should not be accepted here. So from this I can say the value of R equal to square root of L by C. பாத்தீங்களா எவ்வளவு பியூட்டிஃபுல்லான ஒரு ஸ்டெப்பை ஹைட் பண்ணி வச்சிருக்காங்க இந்த சர்க்யூட்ல. See, still but derive பண்ணும்போது you should be very confident till the last step. Definitely you will get the answer. You know the value of L and C already it is given in the question. The value of L is given as 0.02 Henry and the value of C is given as 100 microfarad. Substitute பண்ணிடலாமா? Yes, so I'm doing here itself because we are in final step almost. So let me do it. So the value of R equal to square root of L equal to 0.02 upon this is 100 into 10 power minus 6. If I will bring this 10 power minus 6 to the numerator, it will become 10 power plus 6. So or otherwise you can do one thing. See, 100 into 10 power minus 6, it will become what? 100 can be written as 10 power 2. 10 power 2 into 10 power minus 6 will be giving you 10 power minus 4. Bring the 10 power minus 4 to the numerator. What will happen then? See in the numerator, then you will get, see there already what we have is 0.02 into 10 power minus 4 will become 10 power plus 4. Now further what I can do is, see, 0.02 can be written as 2 into 10 power minus 2. Already 10 power plus 4 is there. Yes, further 10 power minus 2 into 10 power plus 4 will become 10 power 2. So finally what we are having here is R equal to 2 into 10 power 2 square root. But you know 10 power 2 will become 10. So 10 into root 2 will become 1.414. So we can say it will be 14.14 ohm. So the resistance offered by the network for the given circuit, here it is R is equal to 14.14 ohm. Now let me conclude one more thing. It's a kind of tank circuit. We people are calling it as a tank circuit. And the resistor that we have calculated now, it is called a dynamic resistor. And the answer for this dynamic resistance is simply R is equal to L by C. That is the relation when the imaginary part will become completely zero. Now I will tell you few more things from here. Now you please tell me, there is in our circuit, resistor is there, inductor is there, capacitor is there. Now is there any chances for the resonance in the network? Definitely resonance could be possible. Resonance will occur when there are two storage elements will be presenting in the circuit with two different properties. In our electrical circuit, we have only two superstars. One is one inductor, another one is capacitor. Whenever they are connected in series, definitely there will be a chances for getting resonance when we are changing the frequency. In the question starting itself, though they have not talked about the resonance, they told that this circuit will going to have only conductance. It means imaginary part of the circuit will become zero. So it clearly indicates that imaginary part of the circuit will becoming zero only. That point is what? When the imaginary part of the circuit will become zero means that point is called resonant frequency. The corresponding frequency that we are calculating at this point is called what? Resonant frequency. Yes or no? Definitely it will be happening. So the conclusion is circuit almost it is in resonant only, and the formula to calculate the resistance for this kind of tank circuit is simply only for this one. You cannot apply this for all. When the capacitor and the resistor are connected in series and the inductor or resistor is connected in series and they are connected together. In this case, under resonance R is equal to L by C. That is the relation between R and C. Do remember this formula. Just to make a hint, it will be useful for you in the futures. Okay. I hope you all have understand this circuit. Okay, let me drop the next question. It's really very beautiful now. Yes, fine, sir. So let me drop the next question. The next question is, there is one resistor given, and that resistor is connected with the inductive coil. That inductive coil is connected with a parallel circuit that is having resistor and capacitance. Okay, they are connected like this. After that, they will be connecting with the supply. So this is the given network. Now the values given as this is 0.5 ohm, inductor value is 5 millihenry, value of the capacitor is C, sorry this is C, value of the resistance is 1 ohm, this is 1 ohm. Now supply voltage is given as instantaneous voltage is given 100 sine 100 times of t. This is, we all know, we are calling it as instantaneous voltage. Then what is the question? In the circuit given below, the value of the capacitor is required for maximum power to be transferred to the load. If you observe in the network, we are having resistor here. Yes. In order to transmit the maximum power to the load, in order to transmit the maximum power to the load from the source, what can be the value of the capacitor? That's all. That is the question. Okay. Now proceed further. Figure out the value. Take this question as the homework question. Try to bring the answer by yourself. Don't make discussion with anyone. It may be anyone in the sense it is common to all resources. It may be your friend, or it may be your textbook, or it may be your Google, YouTube. Instead of trusting all these people, trust your brain. Try to apply it. If you don't get the answer, but if you are trying, that is enough, because you are teaching your brain. You are not learning, you are training, you are bringing the resources from your brain. So your brain is learning to solve the question. That is very important. Observing the content is different, bringing the content from the brain is different. So you should slowly ask your brain to apply the basics. I taught you these many basics. Slowly now interconnect all those basics and crack this question, crack this question. Like that, when you are teaching with the help of, keep the clock with you, always follow the timer, conscious, whatever the instruction that I am giving, kindly follow it. If you are not following it, then the time that you people are investing to observe the lectures here, the time that you are investing to practice the questions, everything will be wasted. So instead of doing like that, correct whatever I am telling during these sessions, try to apply all those things immediately. You will behave like an instant impulse response. You should change your activities as early as possible, such that slowly, whenever you are trying to solve the question with the help of clock, starting at the time of starting, it may seems to be little difficult to bring the answer. If you are setting the clock for 2 minutes, it may take some 3 to 4 minutes. But slowly, what I told you, use your brain. While solving the question, try to spend maximum number of steps. You should do it by your brain only. You know how to do brain calculation. When I am asking 2 into 2, how you are telling immediately 4? Because you have been practiced. What is the value of 10 cross 5? It is 50. How suddenly coming it's from our brain? We have habituated, we have trained our brain well to do these small calculations, but we have not trained our brain well because we have habituated to the calculator. Whenever we are having something, a big number, why calculation is there? Why we should waste our brain? நம்ம பிரெயினை கொஞ்சம் தூங்க வைக்கலாம்னு சொல்லிட்டு it is sleeping for very long time. So it's time to wake up. It's time to practice. It's time to slowly inject all things to your brain. So ask your brain to do the calculation. If brain will be telling to you, take the calcium you are having, na, it will tell like this. You tell to brain, no, do it by yourself. ஓகே சச் தட் ஒரு சில வேல்யூஸ்லாம் பார்த்தீங்கன்னா இந்த பவர் ஃபேக்டர் கால்குலேட் பண்ணும்போதெல்லாம் 0.8 அப்படிங்கிற வேல்யூ வந்து ரிப்பீட்டடாக இருக்கும். அப்போ காஸ் 0.8ஓட வேல்யூ எவ்வளோ, சைன் 0.8ஓட வேல்யூ எவ்வளோ, இந்த மாதிரி இருக்க வேல்யூங்கெல்லாம் மைண்டில் வந்து நீங்கள் ரெஜிஸ்டர் பண்ணி வச்சுக்கிட்டிங்கன்னா ஸ்லோலி எக்ஸாமில் சால்வ் பண்ணும்போது டைரெக்டாக பிரெயினை வச்சே நீங்கள் சால்வ் பண்ணிடலாம். ஸோ இட் இஸ் வெரி இம்பார்ட்டன்ட் டு கிவ் ட்ரைனிங் டு யுவர் பிரெயின். இட் ஷுட் கம்ப்ளீட்லி ஃபாலோ யுவர் ஹார்ட். ஒரு டைமுக்கு அப்புறம் you should not let the brain to instruct. If he is asking you to solve, you tell to brain, no, I will solve it by myself. That is the response coming from your heart. Heart will always give positive response. Brain will give you based on the information that you have injected to the brain in the past. So you have to change the habit. Okay, fine. I hope you all are be on the track. I have been solved plenty of questions in the AC. It is your responsibility to practice more number of questions, as many questions as possible. Try to solve it. Do it by yourself only. Don't focus on any unwanted things. That is very important. And keep smile while practice பண்ணும்போது smile பண்ணுங்க. Maximum time எவ்வளோ ஸ்பெண்ட் பண்ண முடியுமோ அவ்வளோ டைம் ஸ்பெண்ட் பண்ணுங்க. Okay, in the next lecture I will be solving few more questions. With that we will be trying to wind up the AC, because almost I have solved all the type of question. It doesn't matter whether I have solved all type, but I have given the basic bridge in AC, what we need to do, what we not to do. Okay, so that is sufficient. Let me solve few more question in the next session also, but it is very important the effort that you people are putting. It doesn't matter whether I am solving 10,000 or 1 lakh question. It depends on your effort only. Okay, this is all for this lecture. Remaining